This problem is from the 2024 Harvard-MIT Math Tournament. Feel free to give it a shot and keep watching to see the solution. Okay, so here's how to do it. You'll notice that we have two very similar expressions. And when you have two very similar expressions, you want to think, how can I combine these two expressions to cancel some terms? So how might we combine these two? Well, you'll see a sine squared x here and a cosine squared x here, so maybe we can get this identity involved. For example, maybe if we added this and this, well, we can replace this and this with something much, much simpler. But when combining, when canceling, you want to simplify, or you want to find a way to change the most complicated parts of these expressions into something much simpler. And you can do that with canceling. But, okay, so we could maybe add these. We could also try subtracting these. Subtracting works because, well, if I subtract this and this, I'm going to get rid of the 4. It's going to turn into difference of squares, and I can get this involved. So the highest degree is going to be 2. So let's go with subtraction. Okay, so minus this. Okay, so again, the whole reason why we're subtracting is to get rid of this. Get this to something smaller. Okay, so that goes away. It's going to be cosine squared x minus sine squared x plus sine to the power of 4x minus cosine to the 4x. But this is going to go away soon. Okay, so this stays the same. But we've got difference of squares here. So what does this factor as? It's going to be sine squared x plus cosine squared x times sine squared x minus cosine squared x. Okay, and this is how much again? 1. Okay, so 1 times this, I'll just copy this. And what is this equal to? 0. Okay, wait, so if this minus this is 0, that means this has to be the same as this. I could literally say that this is y, and this also has to be y. So sine y is 13 over 14, what's cosine of y? So that simplifies the problem a lot. And it looks like something we're familiar doing. Okay. So sine y equals 13 over 14, find cosine of y. Okay, so we can just draw out the right triangle. Okay, so this is one way we could draw it. So sine, that's going to be 13 over 14. But there's another way to draw the triangle. How? Like this. And then this would be y. And then it would be 13 over 14. Okay, wait, so which triangle do we use? Well, let's go back to the problem. So this expression is already 1, and then we're adding some other stuff. So I'm kind of leaning towards this quadrant, because there's a good chance that this expression is more than pi over 2. If we can show that this has to be more than pi over 2, then our angle is going to be in this quadrant. So it makes sense to bound this. And by bound, I mean find an inequality where we find the minimum of this. So let's go ahead and do that. Okay, so that's the approach we're going to try to minimize 1 plus sine squared x plus cosine to the power of 4x. All right, so how do we do that? Well, we've got two trigonometric expressions here. It would be much simpler if we were only working with one. So can we get there? Okay, which one should we change? Which one's easier to change? This one. And why is it easier to change? Because we can use this identity. Okay, so I could replace this with 1 minus cosine squared x. And then this is going to turn into 2 minus cosine squared x plus cosine to the power of 4x. Okay, so we did it. Now we only have to do one trigonometric function, which is cosine. So we're trying to minimize this, but what kind of expression is this? If I let a be equal to cosine squared x, then this turns into a quadratic. So this is going to be a squared minus a plus 2. How do we minimize this? We can use negative b over 2a for a quadratic. So it's going to be negative 1 over 2 times 1, which is just 1/2. If I plug 1/2 into here, that's going to be the minimum value of this expression. So let's go ahead and do that. 1/2 squared minus 1/2 plus 2 is equal to, so this is 1/4 minus 1/2 is negative 1/4 plus 2 is equal to 7/4. So the minimum value of this expression is going to be 7/4. And why were we looking for the minimum again? We wanted to know which quadrant we were working with, which triangle to use. If the minimum was more than pi halves, we would be in this quadrant. So let's go ahead and check. Is 7/4 more than pi halves? All right, so this is about 3.14 divided by 2 is about 1.57. This is 1.75. So yes, our wishful thinking paid off. So we're going to be using this triangle. Okay, and then this is going to be y degrees. Oops. Okay, so what's cosine of y going to be? Yeah, so this one's not it. So forget about this one. Y degrees. Cosine is going to be this over this. And how do we find this? By the Pythagorean theorem. So it's going to be square root of 14 squared minus 13 squared. So, okay, so let's see if we can do some mental math here. Okay, so this needs to be negative because we are going to the left. We're to the left of the y-axis. So negative 3 root 3 and cosine, okay, and cosine of y is going to be negative 3 root 3 over 14. This is your answer.